Welcome to our lecture on the three base coat colors of horses. This presentation will talk about the points of the horse, the genes behind the three base coat colors, the red horse or the chestnut, the black horse, and the bay horse. No matter how exotic they appear, all horse coat colors emerge from the three base coat colors. These are the red or the chestnut, the black, and the bay. It is important to note that horses are only capable of producing two pigments. We have the red or the pheomelanin and the black or the eumelanin. So how do we get the third base coat color, which is the bay? To understand how the bay color is produced, we must first need to understand the concept of the points. What are the points of the horse? The points of the horse include the mane, the tail, the lower part of the limbs, and the rim of the ears. These points can either be black or of the same color as the rest of the body. The two main groups of the colors are those with black points and those with non-black points. Every single horse, no matter what its color or pattern, has one of the three base coat colors. For the identification of the coat color, it is necessary to understand the concept of points. So what are the genes behind the three base coat colors? The three base horse coat colors are based on two genes. We have the extension and the agouti genes. The extension gene is responsible for the color of the pigment, either black or red. And the agouti gene is responsible for the distribution of black color to the points. Again, when we say points, it's referred to the mane, the tail, the lower parts of the limbs, and the rim of the ears. Together, the extension and the agouti are responsible for the three base coat colors of horses. This include the chestnut, which is red body with red points, the black, a black body with black points, and the bay, a red body with black points. What is the function of the extension gene? The production of the black and the red pigments is determined by the extension gene. The extension gene has two alleles. We have the uppercase E and the lowercase e. So the uppercase E refers to our dominant allele, while the lowercase e is the recessive allele. These alleles either extend or reduce the amount of the black pigment in the coat. So the dominant allele of the extension gene is responsible for the extension of the black pigment in the coat, while the recessive allele of the extension gene is responsible for the reduction of the amount of the black pigment in the coat. The uppercase allele of the extension gene is what we refer to as the dominant allele. It enables the production of the black pigment in the coat of the horse. It extends the black pigment to the hair as well as in the skin. Because it is dominant, this allele is expressed in both the heterozygous and the homozygous state of the extension gene. We also have the lowercase extension gene, and that is referred to as the recessive allele. So this allele enables the production of the red pigment in the horse's hair, although the skin remains black. Because it is recessive, this allele is only expressed in the homozygous state. When the dominant allele is not present, the extension gene is considered to be switched off. The extension gene is responsible for the horse's base color, either red or black, and all the other genes will act to modify or mask the effects of the extension gene. So this is what happens when the extension gene is switched off and switched on. So when the genotype of our horse is homozygous recessive, it means that the extension gene is switched off, or it is again no recessive. So that the extension gene is not expressed in the horse and the horse becomes red. When the extension gene is expressed in the horse, it means that the genotype of the horse is homozygous dominant or heterozygous for the extension gene. When this happens, the horse is phenotypically black in color. Now, because the extension gene is expressed, or the black pigment is expressed. Another important gene is the agouti gene. The agouti gene is responsible for the distribution of the black pigment on the coat of the horse. The effect of this gene is to restrict the black pigment to the points. So these are the mane, the tail, the limbs, and the ear rims. The rest of the body will be switched to a red shade. In other words, the agouti gene inhibits the action of the extension gene on the body of the horse, but not on the points. The agouti only modifies the black pigment. It does not act on the red pigment. So, if there is no black pigment to distribute, then a gene determining the distribution of the black pigments can have no effect. The uppercase letter A is what we call the dominant allele for the agouti gene, and it restricts the black pigment to the points. Because it is dominant, this allele is expressed in both the heterozygous and the homozygous state. We also have the recessive allele of our agouti gene. It enables the production of the black pigment throughout the entire coat. Because it is recessive, this allele is only expressed in the homozygous state, i.e., when the dominant allele is not present, or in other words, when the dominant allele is switched off. The agouti gene is responsible for the restriction of the black color in a horse, so that when the agouti gene is switched off, so meaning that there is no restriction, the coat color of our horse will be entirely black. It also means that the genotype is homozygous recessive for the agouti gene, or the dominant allele is absent. When the agouti gene is switched on in our horse, this means that there is the restriction of the black color to the points, the mane, the limbs, the tail, as well as the edges of the ears. And that is why the color of the horse will be red or chestnut in its body, and the points will be black in color. In terms of the genotype, so our genotype will be homozygous dominant for the agouti and heterozygous. The extension gene is responsible for the production of the black pigment, or the expression of the black pigment, so that when it is switched off, the horse becomes red. When it is switched on, it becomes black in color because it is expressed now in this state. In the presence of the agouti gene, so when the agouti gene is switched off, so again, the agouti gene is responsible for the restriction of the black pigment, so that when it is not present or it is switched off, so there will be no restriction, so that the horse remains black in color. When it is present or when it is switched on, so that is the time that the black color will be restricted to the points as seen in this diagram. So again, in the absence of the extension gene, or when it is switched off, so the horse becomes red. And in the presence of the agouti gene, or when there is the presence of either a dominant, heterozygous, or a recessive allele of the agouti gene. So as you can see here, there is no effect on the color. There is no color change. Again, because the agouti gene does not act on the red pigment, it only acts on the black pigment. So that the horse stays the same, no? So it is still red in color. So this is a summary of the genotype of the bay, the black, and the chestnut horses. So for the bay horses, they have both extension and agouti gene that are turned on. So we have here either dominant, no, homozygous dominant, heterozygous, and the same is true for the agouti. We have dominant and heterozygous. So bay horses have both extension and agouti turned on. Now for it to be bay in color. For the black horses, they have extension turned on and agouti turned off. For the chestnut horses, they have extension that are turned off and are indifferent with agouti. So um, there is no really effect of the agouti for the chestnut, no, because again, for the chestnut, it is red in color. So again, the agouti will only influence, or it will only restrict, it will only act on the black pigment and not on the red pigment. So that regardless of whether the agouti is dominant, homozygous, heterozygous, or recessive, so it has no effect on the color, which is the red color, coat color of the horse. So together, extension and agouti are responsible for these three base colors, the, the black, the bay, and the chestnut.